Hello, and welcome to Section 5.5, Video 2, Part 2 of 3 videos. In this section, we'll be continuing talking about our inverse trig functions. Specifically for this video, we will be looking at the inverse cosine function. So in video 1 of section 5.5, we looked at the inverse sine function. Now with the cosine function. For this one, if we look at our basic cosine curve, the first half of one period of the cosine function takes us from 0 down to pi. This will be the domain that we're restricted on. So for our inverse sine function, we were negative pi over 2 to positive pi over 2. And it ended up being the right half of the circle. For this one, if our domain goes from 0 to pi, so from 0 down to pi, then our range is what? Well, it's 1 to negative 1. Negative 1 to 1. The formal definition says that the inverse cosine function is the function we write it with the little -1. So in the first video, we had the sine with the little -1 as its exponent. In this case, we write it as cosine with the -1 as the exponent. And this tells us it's the inverse cosine function. So inverse cosine function, and remember, when we're talking about the inverses, the domain and range changes. So the inverse cosine function has domain negative 1 to 1. And range zero to pi. And this is defined by we say that the cosine inverse of x equals y. This implies that the cosine of y is equal to some value of x. So much like with our inverse sine function, we're basically just trying to go backwards from a value we're given to what would that value of cosine be. I'm going to erase this. If you need to pause the video, feel free. I stressed to you guys when we were talking about our inverse sine function that it was the right half of the circle. Whatever value we ended up with as an answer had to fall on the right half of the circle, because we were talking about negative 2 pi to pi over 2. Well, here, because we're talking about 0 to pi, that's what? That would be the top half of the circle. So when we do these inverse cosine functions, the value we end up with has to be in that top half of the circle. If it's not, we do not have the right answer. So let's look at a couple examples. Let's say we want to find each value. And the first one, we want the cosine inverse of square root of 3 over 2. So, if we are talking about the top half of this circle, where would the value for cosine be equal to square root of 3 over 2? Well, that is when we are talking about our radian measure of pi over 6. So in the top half of the circle, at pi over 6, that value would be square root of 3 over 2. So again, remember the inverse function is kind of going backwards from our ending point to get to the starting point. If we have cosine inverse of 0, well, where on the top half of this circle is cosine equal to 0? Well, that's when our radian measure is pi over 2. And again, we're concerned with the top half of the circle because cosine of 0 could be two different measures, right? It could be pi over 2, it could be 3 pi over 2. But because we're only concerned with the top half of the circle, that's why we end up with a value of pi over 2. All right, and let's try a couple more here. Similar to the last problems that we looked at in the first video for inverse of sine. Again, let's say we want to find each value, and we want cosine inverse of cosine of 2 pi over 3. So just as in the inverse sine function, we're going to do this sort of in two parts. We're not going to worry about the cosine inverse function in front. First thing we just want to look at is what's inside the parentheses. So sort of like your order of operations. So where or what value is cosine of 2 pi over 3? Well, this would be what? This would be minus 1/2. So now we can bring this down. So we want to know where on the top half of the circle is cosine inverse equal to minus 1/2. Well, that gives us just back to our 2 pi over 3. Why does it just give us that value back? Because where we started was already in the top half of that circle. We were at 2 pi over 3, so we're going to get that same value back. And again, there's the shortcut method you can do to this, but I prefer not to show you guys a shortcut method because sometimes that can get people into trouble. I think it's just easier if you do what's inside the parentheses and then do the inverse function on that. And let's look at what we're talking about with that. So let's say we have cosine inverse of cosine of 5 pi over 3. So now this is where if you're using the shortcut method, you don't just want to put 5 pi over 3 because 5 pi over 3 is not in the top half of the circle to begin with. So the methodology we would have to use is the same that we just did. And so if that's the case, cosine of 5 pi over 3 is what? Well, that's down here in quadrant 4. Actually, I guess it's more like this. So this value is what? This is 1/2. And cosine inverse of 1/2. So what value in the top half of the circle is cosine equal to 1/2? Well, that would be pi over 3. So you see, you don't want to just say, oh, well, whatever inside the parentheses is our answer, because it's not always the case. It's only if we start in the top half of the circle, because that's where we need to end up. But if you do this method here, you'll always get the right answer. You're not going to get in trouble with trying to do any shortcut methods. So that wraps up video 2 for section 5.5. One more video to go. We'll see you guys in that section.